Hello everybody. Next, let us look at how to find out the velocity kinematics of a cylindrical manipulator. Now you might remember this image of cylindrical manipulator. This is again the same image when we did the DH convention for finding out the forward kinematics. So for finding out the velocity kinematics, as I have discussed previously, we require the same link parameter table, and based on that we will get A1, A2, A3 matrices. I'm not going to repeat the same thing here because the forward kinematics of cylindrical manipulator has already discussed this. So based on this particular uh, manipulator structure, we get the value of A1, A2, A3 based on this link parameter table and this matrix. Together we will get the value of A1, A2 and A3 as this, where I have written theta 1 theta sorry d1 d2 and d3. uh, One small correction I have to do here: I should avoid writing star here, because once we write it in matrix we don't write it star. If you remember, the star we used to write when it was actually a variable. It's a variable in the table, but once we write in matrix we avoid the star. Okay, so this is a1, a2, a3. Now coming to the structure of the Jacobian, what is important to realize here is that the first joint is a revolute joint, the second is a prismatic, the third is also a prismatic, and based on that we can actually write the Jacobian based on what we have already studied. We have seen here, if it's a prismatic we will use this one, if it's a revolute we will use this. So based on that, let us write the Jacobians. J, since there are three joints, so it should be 6 by 3 matrix. That will be given by the first matrix, sorry, the first column. Since this is a first is a revolute joint, so the first one that we are having here is a revolute joint. So I is equal to 1. It's a revolute joint. So instead of writing revolute, I can write a small r. Anyway, so what is the requirement for revolute joint? The revolute joint is basically, it is given by this equation followed by the bottom one, which is this equation. So I will write this equation as such. So let me write it. This becomes 0 r I minus 1. I is 1 here, so it is 0 r 0 multiplied with 0 0 1, then multiplied with d 0 d n. Here n is maximum is 3, so 0 d3 minus 0 d I minus 1, which is 0. And here in the bottom it will be just 0 r 0, then followed by 0 0 1. That's all. So this is for the revolute joint. The second and third, both of them are prismatic joint, and we already know the equation for the prismatic joint. It's just the first half, it is 0 r I minus 1 0 0 1, and the bottom part is just all zeros. So based on that, I will write here I is equal to 2, which is a prismatic. It's a prismatic, and then we are having 0 r 2 minus 1 is 1, so 0 0 1, and the bottom part is all zeros, 0 0 0. The third column is I is equal to 3, and this is also a prismatic joint. This is also a prismatic joint, so it should be 0 r I minus 1 is 2, 0 0 1 followed with 0 0 0. So this is the Jacobian matrix which we have to find, and then finally we get the velocity kinematics. So we all know that first we have to find out 0 t0. 0 t0 is already known. We know 0 t0 is identity matrix. So I will just straight away write, we know 0 r0, it's always going to be identity matrix. So identity matrix, which is therefore if I am going to multiply 0 r0 with the 0 0 1 from the identity matrix, if I multiply 0 0 1, basically I will get only one answer, and that is 0 0 1. After this we have to multiply it. Now this multiplication is cross multiplication. So first I will write and 0 d3 I have to find out. Okay, so first 0 d3, so let me keep this one here because 0 d3 I will be able to only find it a little bit later. So let me keep this one here. I have not yet completely found this one. The bottom one is same as this one, so that's not an issue. I will go for the next one. So I will again, and for the next one 0 r1 I have to find. So and 0 t1 is equal to a1, therefore 0 r1 as we can see a1 is this one. If I take the 3 by 3 matrix here, that will be the one, so I can directly write this one as the matrix which is having cos theta 1 minus sin theta 1 sin theta 1 cos theta 1 0 0, the last is 0 0 1. And if I want to find out 0, if I want to find out this value, then I will have to multiply with 0 0 1. So if I multiply it with 0 0 1, I will get, and 0 r1 multiplied with 0 0 1, if I am going to multiply, so as you can see I will take only the third column. So the third column, the answer will come as 0 0 1. Correct. So that is also done. The next one is 0 r2. I have to find out 0 r2. So I will write and let me write it properly, and 0 t2 is a1 into a2. Now if I multiply a1 into a2, which is basically if I am going to multiply these two, as you can see the first column multiplied with rows and then finding out, basically what will I get? I will get the answer as, and based on this I can find, say I'm interested in basically the third one, na? So it is 0 r2. So 0 r2 will be the 3 by 3 matrix, the 3 by 3 matrix that I am having here. That matrix I have to multiply it with 0 0 1 here, 0 0 1. So 0 0 multiplying with 0 0 1 means taking only the last column, 0 0 1, because the others will be multiplied with 0. You will have to take the last column 1, the last column 1. So I can basically write this as, so let me directly write so multiplying this directly with 0 0 1, I'll have to take just the third column. The third column is going to be minus s1 c1 0. So that is also done. Now what is left is this part. Now here remember this multiplication is of cross product. So whatever is the answer we have got for this one, which is actually we have found out here, that we have to cross product with this value. Now what is this? 0d3. 0d3 is basically when you get 0t3. From that we have to take the 0d3. So I will have to first find out 0t3. Also 0t3, which is a1 into a2 into a3, will be given by this, and then from here we can get 0d3, which is the last. See, so this is basically a matrix which is having 0r3, 0d3, 1, and there are 3 zeros. So the 3 zeros are here, the 1 is here. So what is 0d3? 0d3 is this. Okay, so that part we should not forget. So basically taking 0d3, sorry, so based on that I will complete this. Okay, therefore I will get 0d3 minus 0d0. Now 0d0 means I will get directly from 0t0. If you remember, 0t0 is basically, if I take the previous problem, yeah, if you remember here, if you look at this point, the last d 0d0 is 000 itself. There is nothing. Why? Because obviously 0d0 means trying to move the frame from 0 to 0 itself, so that is not going to be an issue. So this is going to be directly, I can write the answer here. So this is going to be, taking it, I will get basically minus d3 c1 d3 c1 and d1 plus d2. That is going to be my 0d3 minus 0d0. Now that I have to cross multiply with, cross product with 0 r0 into 001, which I have found out here as 001. So this whole term I can write therefore as, 0r0 001 cross multiplied with 0d3 minus 0d0 is going to be cross multiplying 001 with this portion, this equation. So I will take that as such and I will use that here. So that same equation we are going to cross multiply. So how do we cross multiply? That also I should just show here, otherwise it will be an incomplete. Therefore I will have the cross multiplication as, so let me directly draw here, that is going to be equal to ijk, 3 values ijk, and then I am having 001 and minus d3 c1 minus d3 s1. Sorry, this one should be s1. Sorry, here it should be s1. Here it should be s1. So it is s1 here, s1 here, and similarly here also it will be s1. So this will be d3 c1 d1 plus d2. This cross multiplication, if I am going to do, I'll get the answer as, since I am going to do it first time, I will just show it. So it is 0 into this minus this. So it is going to be 0 into d1 plus d2, that will be 0, minus 1 into d3 c1, that is going to be my I component. So it is all I component, j component, k component. Similarly, for the next case, for the j component, I will have to multiply the corners of the matrix, and that means for j I'll have to first write minus j, that I have to take care. So it will become minus of, now 0 into d1 plus d2 is going to be 0, minus of 1 into minus of, so this will become plus d3 s1 of j, and finally k will be all 0. As you can see here, k is going to be all 0, so it is be plus 0 k. This can be actually written as, our vector form as minus d3 c1, then minus d3 s1 and 0. So this is what is going to be the answer for this particular portion. So what I have done here, I have basically tried to find out this value. Okay, so when I tried to find out that value, I got this cross multiplication and all as the answer, cross product as the answer. So based on that, I am trying to define the answer here, and we have very clearly seen that this is going to be the answer for the case. And based on that, this portion I will substitute now in the Jacobian. So now finally I have to write the Jacobian. Therefore the Jacobian matrix will be, the Jacobian matrix is, now I have to substitute, instead of this individually all of this I have to substitute. So as you can see here in the bottom portion, it is all zeros, 0 r 0, all these values I have found out here. So first, this multiplication is the last one I found out. This one, as you can see, 0 r 0 is basically this. So I will first write, the first one will be J matrix is having the first three values is going to be minus d3 c1 minus d3 s1 0 for this value. And the second portion that I have to see is, the bottom portion is basically I have already calculated it here, so it is 0 0. Which one I am talking about? This portion I have already calculated here, so it is 0 0 1. So let me write that. So it will be 0 0 1. The next is the second column. The second column is 0 r1 0 0 1, which we have already found out here, which again comes out to be 0 0 1, and the last portion is 0 0 0. So this one here will be, according to equation, it will be 0 0 1 followed by 3 zeros. Finally the last one is again 0 2 0 into 0 0 1, which we have 0 to 0 into 0 0 1, which we have minus s1 c1 0. So that if I am going to write here, I will get minus s1 c1 0 followed by three zeros because it's a prismatic one. Again, it will be just three zeros. So this is the Jacobian matrix. And the final, the, the velocity kinematics is given by, so let me write that properly. And the velocity kinematics, if you remember, it is 0 vx3, 0 vy3, 0 vz3, then 0 omega x 3, 0 omega y3, 0 omega z3. This is going to be equal to, according to our equation of velocity kinematics, I have to write the Jacobian straight away there. I will take that Jacobian straight away and I will place it here. That, let me change the color. That multiplied with the three joint variables. Which are the three joint variables here? Here the three joint variables are theta 1, d2, d3. Should not forget theta 1, d2, d3. So based on that, I will be able to write straight away into theta 1, d2, d3. This is just normal multiplication. Normal multiplication when I am going to multiply, so I will be getting the value one by one. I can get the values here. So this should be theta 1 dot, d2 dot, d3 dot, because that is the equation according to the kinematic equation. So now I have to find out 0 vx. So I will write therefore 0 vx3 or just vx. The x direction velocity, we just write vx sometimes. Okay, that will be, according to this equation, I have to multiply both of this. So I will just write, for the sake of multiplication, this one will be theta dot, this is going to be multiplied by d2 dot, this is going to be multiplied by d3 dot. So now based on this equation, vx will be minus d3 c1, that is c theta 1 dot, that is d theta by dt, d theta 1 by dt, sorry. Then the next one is 0, so I am not going to write that. The third one is plus, not plus, minus, plus of minus s1, that is s theta 1 into d3 dot. Similarly, 0 vy3, which can be written as vy, or the velocity of the end effector in the y direction, it will be, as you can see in the equation, multiplying, we will get minus d3 s1 multiplied with theta 1 dot plus c1 into d3 dot. And the next one is going to be 0 vy, not vy, vz3, sorry, to write it in subscript, that is going to be equal to vz, that is, according to this equation, only d2 dot, because the rest all is multiplied with 0. Now omega x is going to be all multiplied with 0, so I will write here, or I can write it down, let me write it here. Let me write it down so that it's a little bit more clear. So I will get 0, or I'll get straight away right, omega x is going to be all zeros, omega y, the angular velocity omega y is going to be all 0, whereas the last one, omega z, is going to be equal to just d3 dot. So here is the equation that gives the velocity, linear velocity and the angular velocity of the end effector based on the velocity of the um, joint variables. Now I can write this in expanded form as minus d3 cos theta 1 into theta 1 dot plus minus of sine theta 1 into d3 dot. Similarly, this one also I can write it as minus d3 sine theta 1 into theta 1 dot plus cos theta 1 d3 dot into d3 dot. So with this we finish the velocity kinematics of cylindrical manipulator. So what are we doing? We are finding the end effector velocity equation with respect to the joint variables. Thank you.